Hello. Hello, Mr. Robinson around here. Remember, we talked about the longest palindrome substring yesterday, yeah? So let's review this a little bit, yeah? So this is on square. The key thing of yesterday is what? This palindrome check is on time, right? So if we put all these together, which is a very basic, naive brute force, and I will take on qubit because this is very expensive to check. This is it happens every time we want to find out if a substring is a palindrome, and that takes on time. That's very expensive. So how do we improve it? We can use the dynamic programming. Yeah, dynamic programming. This is dynamic programming equation. Yeah, to find out to compute any substring to see if it's a palindrome, right? So we are reusing. Look, Fij representing if the substring from I index, J index included is a palindrome. And then for each substring, we are not calculating every time. We are not calculating, like a whole string. Instead, we use the Fi plus 1 and J minus 1. So this is kind of reusing the previous result, which is bring down the complexity from on qubit to on, right? So, and we can also implement this using top-down dynamic programming, which is recursion with minimization with cache keyword. Right?
Yeah.
So that's on qubit. That's a way for us to find out the longest palindrome substring in on square time, right? So this is on square. This is on square. 2 on square is 2 times n square, which is on square. Because when we talk about the time complexity or all space complexity, we drop the constant, right? Do you get it? Okay, so now today actually we have another diagram. Yeah, we have another diagram. How many palindromes can you categorize? I mean, how many palindromes? What's palindrome by the way?
When you reverse it, it's still the same.
Can you give me an example?
Race car, ABA.
Race car, and then every back to, yeah, poo. P-O-P, eh? No, not poo, okay? P-O-P, pop.
P-O-O-P, that's what he said.
Alright, okay. Reverse it, yeah? So reverse it. If this is S, in Python we use this syntax. S, minus
Counter.
1 equal S, right?
Counter.
Or we use the 2-pointer thing, yeah? 2-pointer.
Or counter.
What counter? No, the counter doesn't help this case. Look, the 2-pointer thing. So look, I and J, it's the same. I and O and O, it's the same. Okay, when I meet, it's a palindrome, right? And if this is not a palindrome, let's say D, okay, the same. Okay, the same. But if I change this to the, okay, not the same. Not a palindrome. Okay, 2-pointer thing, easy. Okay, so coming back to the question, how many kinds of palindrome? How many kinds of palindrome? How many kinds of palindrome? Yeah, what are they?
Odd and even.
Yeah, odd number, odd characters, or even characters. So for example, odd characters A, B, A. Yeah, even number A, A, B, B, A. Yeah, you see? So you see the difference, yeah? With the odd number, odd characters, the one in the middle, right? The one in the middle, yeah, is just could be any, right? It's a single one, right? For the even, and every character has to match another one on the other side, right? Okay. So let's look at this A B B B A, maybe C. Okay, what's the longest palindrome here?
A, B, 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 A.
Yeah, exactly. So.
Or C, A, B, B.
Yeah. Okay, let's look at this example.
A, C.
Yeah. So if we can treat it, we can go through this A. Yeah, we can use it as a center to expand, right? Okay, it doesn't go any. B, I can expand. No. B, look. The thing is that if I use 2-pointer, I can expand this. I can use this as a center, which doesn't give any more any palindrome other than this B, right? If I can use these two, right, and that's 2, right? The same B. So if I use this as a center, then I can expand. Look, if I try to use this B, okay, and then I can go both ways. B, okay, yeah, okay. So the longest palindrome character is, yeah, 5. Okay, got it? The same as, look, the similar thing, yeah? A, B, B, C, C. Okay, another one. So, look, if I have two pointer I and J here, right? And then I can let the pointer go both ways, go 2 ways, yes? So B, C, right? Yeah? Do you get my point? Yeah? So let's say we have an expand function. Expand. What's expand? Expand, yeah? Expand. And then take 2 parameters I and J. So I and J means the center of a palindrome. We're looking to expand, okay? So it could be I and I means that it's an odd number palindrome, or I plus 1, which is, okay, so
Even.
okay, so why this is the odd number and why this is the even number? Anybody?
Because
The center, if it's the index, the center is the 1 character, it should be even, it should be odd, right? The center is 2 character.
And then, so it will be odd, but then you plus 1 to make it even.
Which one you're talking about?
The bottom.
The bottom one, the center will be 2 characters, neighbor. That always will be even, right? Okay? You're talking about the first one. So the center, if it's a 1 single character, and then you expand, you let the pointer go the opposite direction, right? Go opposite direction, then that will be odd number, right? So we can use this expand and then to remember the longest distance that both pointers can travel, right? If we remember the longest distance they can travel, then we find the longest palindrome. Make sense? Mm-hmm. Does it make sense? Am I right? Mm-hmm. These 2 pointers, and yeah. So every time I start checking, I have 2 choices. I start checking the palindrome by expanding around the center. So it could be 2, right? It could be even or it could be odd. When it's odd, the center is 1 single character. When it's even, it's 2 characters. And then I let 2 pointers go, they separate the opposite direction. And then let's see how far it can go, how far it can travel, right? And then you stop, right? You stop, and then we can see how far the distance is. That's the length of the longest. That's the length of the longest palindrome. Okay. Basically, that's how we use this expansion around center thing. So we just quickly write this. Okay. Let's see. So n equals length s. Okay. Let's define this expand. Expand the center. Okay. L and R. Okay. Okay. Yeah. So while L is bigger or equal than 0 and R is smaller than n, right? So look, these 2 pointers cannot go beyond the boundary. Am I right? Yeah. And SL equal SJ SR. Okay. So look, Eric, Ryan, come on. This center, when the characters at these 2 pointers match, the L goes to which way? Up. Sorry? Look, this is L, this is R. Okay, suppose this is center, okay? And the characters are the same, like AA. And then which character? L, what should L move? What should R move? Yeah, L should move this way, R should move this way, right? Mm-hmm. Exactly. And if it's a single character, L and R, it go this way and this way, right? Exactly. So L minus equals 1 and R what? R what? Easy. Plus equals 1. Plus equals 1, okay? And then return. We want to return. Because when the loop terminates, right? The L and R points to an invalid position. So we need to return its previous state, which is L plus 1 and R minus 1, right? You see?
Yeah.
Everyone, okay, let me repeat it. When the Y terminates, the L and R pointer points to the invalid state, which could be smaller than 0 of outer boundary, or SL not equals SR, right? This is basically invalid for palindrome. So that's why we return its previous state, which is L plus 1 and R minus 1. Okay, with that in mind, so with L at the beginning, L equals maybe, minus 1. L equals 0, R means minus 1. Okay, we just set the look at the beginning, air is 0, r is -1. Okay, so this is opposite. Why we need that? Because in this case, the length will be r minus air, which is -1, right? Right. So the minimum palindrome length would be one character, right? Yeah. So we need to choose this initial state carefully. Okay, then we can go through this for I in range n, right? So now a b equals expand I, right? And then we check if b minus a bigger than r minus air, then we remember air r equals ab. Okay, and then another choice. Okay, look, this is for the odd number of characters. And what's the second choice? What's the other possibilities?
Even.
Even. So I should put I, and what's the second parameters? If it's even, a b equals expand I. What's the second parameter? Anybody? And then this is the same. I copy again. Here. I single character. And if it's two characters, what parameters should I use? I. What's its next characters?
I+1.
Exactly. So this is I+1. Okay. And then we copy this. We need to check. It look because this function returns the longest, the palindrome. Yeah, the palindrome of the left boundary and right boundary. And then b minus a means that the length, yeah, roughly the length actually is +1, but in this case you have we can +1 in both cases, so we don't need to +1 here, right? B minus a bigger than r. This is the correct. This is the existing, the longest palindrome substring, right? If we find a better one, then we remember the left and right boundary, right? Do you get it? And then we return what? And then at the end we return s air to r +1, right? Yeah? It's easy to implement, yeah? Yesterday we talked about the brute force and we optimize it by dynamic programming, right? And then the code, you have to write lots of code, right? But for this one, not much code to write, right, Eric? Yeah, okay, let me repeat this one more time, okay? So how does that work? Look, let's try another example, okay? ERICAA CDEF. Okay, what's the longest palindrome?
CAAC.
Okay, so look at this I, yeah? This is I, yeah? I'm going here.
That obvious.
Yeah, look at I, yeah? So I try I, okay? And I also try I and I+1, okay? So if I try look I and I+1, and here, I go both way. Okay, so that character is four characters, the palindrome. Do you get it? Yeah? Okay, then if I have another one, this is BA. So then in this case, we try the middle one, I, and then we expand around the center, B, A, C. Got it? Yeah? This is basically what the expand function do, yeah? B, A, C. And then return the left boundary, which is here. This is left, this is right. Right? And the length will be r minus air +1. Do you get it? Yeah, and that's what it's doing here. Look, this is okay. One more question, last question. Why this is there's I and why there's I+1? Come on.
Because I must be the same, because if you have something like ABA, the center is just one, so
Yeah, I and I.
left and right.
Okay. And then what's I and I+1?
So if there's something like 2.
Okay, where's air? Where's R?
Okay, L has to be here, R has to be, they both have separate, since the middle is about
Yeah, okay. And what's this expand function doing?
it's just opening the part and just checking if they're the same.
Okay, so look, if this is, look at the, okay, I write this function, A, B, C, B, D, C, B, A, X, Y. Okay, so if I is here, okay? So expand AR. So what's the, so look, it points them to the middle, A, B, C, B, A, yeah? So after the expand, what does it return? Where is the air? Where is R? you know, if the S is Y, A, B, C, B, X, and then A or R points to C. Where's the A? Where's the?
Left is A. Yeah, that A. And R is real A.
Well done. Yeah, you got it. Yeah. Do you understand? Right? Yeah. Okay. Well done. That's it for today. Bye bye.
Bye.
Bye bye. Oh, one more thing. The time complexity. We go, look. This is n character. We go through this. That's n. And for each one, we need to expand. That takes n. So what's the time complexity? Look. This is n. On.
Square.
This is on. On square. Yes. On square. Okay. That's it for today. Bye bye.
Bye.
Bye. Good job. Bye bye.